Tim? Okay, let's make sure that one's on. Good evening, everybody, and I want to thank the best school in the state for inviting us up and arranging all the logistics here. I really appreciate that as a former Cougar. As a current Cougar, actually. Once a Cougar, always a Cougar. Okay, so this is me. I have my business card up here if anybody's interested. And I wanted to begin here just by explaining kind of how we're organized so you don't get confused with the fact that I'm speaking, because Amber Korfman in our Northwest Regional Office, Amber, I'm outing you, she's sitting in the front row here, raise your hand please, is your contact for Island County issues related to biosolids management. That doesn't mean that I won't speak to you, but if you have questions about a specific facility or activity or permit, you really need to start with Amber. If you have general questions about biosolids, you can certainly talk to Amber, and I would recommend that because you're dealing then with the person who would deal with any specific questions you might have about a facility later. But I'm also available. There are other staff at headquarters and throughout the state that provide support to our regional staff as well. But I'm not the facilities guy anymore. I've done that in the past. Okay, the first thing I want to go through here on biosolids management, and I was asked to address the permitting end of it. We could spend all day talking about permits and then more time on another day. It's an ongoing educational process, even for the people that are engaged in the permitting process of facilities. We are always working with people to make this go, but there is a sort of a legal provenance, a sort of a pedigree to the program, if you will, that I like to make sure people are familiar with. So what happened back in 1993, EPA came out with 40 CFR Part 503, which is their regulation for the management of sewage sludge or biosolids. And they adopted that pursuant to the Federal Clean Water Act. Congress told EPA, go write regulations for managing biosolids. So EPA did that. And the way government works, and many of you may know this, but some people don't, we can't write a regulation. EPA can't write a rule. We can't write a rule unless we have a statutory authority. So at the federal level, the Clean Water Act is that statutory authority. In Washington State, it is RCW 7095J. And our legislature was forward-thinking enough to actually pass unanimously that statute in 1992, a year before the EPA regulations came out. They saw that coming and were ahead of the game. I don't think that happens a lot anymore, but it did back then. The state program, we're required by law to at least meet federal program requirements, and you can kind of debate some of the nuances if you want, but we do, our program does implement. In fact, if you look at it, you'll see a lot of the same exact language in our program as is in the federal rules. We implement our rules through a statewide general permit. That current permit will expire in September of next year, and then it'll be replaced. I'll talk about that more later. But compliance, regardless of the permit, regardless of the status of anybody's coverage under the permit, everybody is required to comply with the rule. So that's kind of, like I said, the legal pedigree to the program. So what are biosolids? I don't realize people have differing opinions on this, but just objectively, residual solids from the treatment of wastewater at a publicly owned treatment works, and that would include Oak Harbor here, or the Coopville facility where the septage is being taken, or at a private treatment works that treats only domestic sewage, treats only sewage. Sewage actually by definition is domestic wastewater. It includes septage from on-site sewage treatment and similar systems, as you all know. It does not include industrial wastewater facilities. So if you're in an industry with a wastewater treatment plant that is strictly for your industrial wastewater, that is not considered or included in biosolids management. That's regulated separately as solid waste. And biosolids are sewage sludge that meet the criteria for beneficial use. Until it's been tested and demonstrated to meet certain criteria, and I will get to those, including the Class A and Class B, it's just sewage sludge. Once it meets criteria, then we call it biosolids. And the state program is deliberately designed to maximize beneficial use of biosolids statewide. And actually, beneficial use of biosolids is the predominant management choice nationwide. So, how do we characterize biosolids? How do we know when something is biosolids and it's not sewage sludge anymore? the first thing that we look at, or not necessarily the first thing, but the first thing we usually think about is pathogen reduction. Biosolids, sewage solids does contain pathogens. Those are things that can cause disease, but just what you have to remember is that there are pathogens, you're carrying them on your body right now. They're in this room, you come in contact with them every day. So it's not like there's one pathogen down the block someplace hiding, waiting to jump out and get you. They're just common in the environment. But certainly we know that we don't want to have sewage just spread on the ground without taking some steps to control pathogens. So we have two classes, Class A and Class B. Class A is actually I'll talk about Class B first. Class B is actually a 99% reduction in potential pathogenic organisms, measured generally by analyzing fecal coliform bacteria that are in the biosolids. They start out at an estimated 200 million, and they get them down to 2 million per gram. It's measured on a dry weight. Somebody asked that question, per gram of dry solid material. But that's Class B. Class A is virtually pathogen-free. It's a 99.9% reduction in pathogens. And most Class B processes, I think it's virtually, I mean, not virtually, just is flat pathogen-free. Most of them go through a very high temperature or lime stabilization process. It's very effective. So we take care of the pathogens. We have a thing called vector attraction reduction, which is akin to odor control. And either you have to treat it in the treatment works to meet standards for vector attraction reduction, or if you don't, you have to inject it into the soil directly when you apply it, or you have to till it in within a few hours after you surface apply it. And that's to control the odors and also to control things that might be attracted to those odors. And then the pollutants, that's the third leg of the stool when we're talking about biosolids quality. And there's been a lot of focus in the years on metals. Most of these are metals, actually. Some of them aren't. But arsenic, cadmium, copper, mercury, molybdenum, nickel, lead, selenium, and zinc are the ones that we regulate. Those are the ones that way back when EPA went through and said, we know quite a bit about these. There's a fair amount of them in biosolids. We want to make sure that we don't have excessive amounts of lead. Nobody wants lead or arsenic in their soil, so we have regulations for those. And there are two levels, just like with pathogen reduction. There's a ceiling limit, if you're up here, you're bad, but maybe you could land apply. If you're down here, you're clean, and there are benefits for being down here. Virtually all the biosolids in the state are not just down here, they're way down here in terms of comparison with the numbers you'll see in the rules. So permitting under the state program, it's applicable, and I don't want to, this gets really dry and bureaucratic after all, so I'm going to kind of run through this quick, but it's applicable to what we call treatment works treating domestic sewage. Sewage treatment plants, simplest way to think of it. And all of them have to come under our state general permit. They submit a notice of intent to us telling us that they will come under the statewide general permit. That's just kind of a way of confirming that we've got a handshake, that they know they have to do it. It's not very complicated. Then they come with an application after that. And we look at applications, their status, three ways. We receive the application in the office. That doesn't mean a lot. It means we've got it, and that's important, but we haven't looked at it. We review it to determine if it's complete, and that is important because until it reaches a state where we consider it to be complete enough, we can't share it with the public because we don't want to share something that's not well done. So if it doesn't look good, we're going to send it back and say, you didn't provide enough information, you need to answer these questions. And then once we've gone through that process, there's a final decision, which typically we approve something, but not everything necessarily has to get approved in a permit process, but that's the end goal. There is a thing called provisional approval, which basically says once you submit your application and jump through a couple of other hoops, you're covered under the permit. Even though we haven't given you final approval yet, what it means is we get to come back at a later date to the treatment works and say, okay, you've been covered, but now that we've looked at it, we have some things we want to discuss with you. We want to fine tune this a little bit. So it gives us the right to come back and make sure that the conditions in the permit that apply to a specific facility can be applied. Otherwise, when you issue the permit, it's a done deal and you got to wait 5 years before you can change anything. Everybody has to comply with the permit, and they're subject, as I said, it's subject to changes. So if we change something with the facility, they have to comply with those new requirements. And all of that, the applications all differ based on the nature of the operation. Treatment plants, there's 375 of them in the state, and there's a broad range of treatment plants, treatment works, and operations. Okay, some key permit elements, things that you might find in a permit if you looked at it. We got a basic application with name, rank, and serial number stuff on it. It's not really very exciting, but it's where we start. You might find construction plans and engineering reports in that permit, and you might find a transportation safety or spill plan in there if they're transporting biosolids. The stuff that people tend to get more interested in and where we spend more time focusing is on the site-specific land application plan. If there is land application proposed, not every treatment works does land application, but if there is land application proposed, there's a lot of stuff that has to go into that permit. We want to know about the past history of the site, the crops that are being grown, agronomic rates, how are you calculating those, how do we know that you're putting on the right amount of nitrogen, how are you applying the biosolids, when are you applying the biosolids, how are you handling on-site management, including where are you storing the biosolids. Soil data, existing concentrations of nitrogen, and for new sites we ask them to sample for pollutants as well to make sure that we aren't applying to a site that, say, already has a high level of maybe arsenic or lead in the soil, then we wouldn't want the biosolids to go there. How they're going to control site access if necessary, and maps, detailed maps, topographical maps, soil maps, maps showing fields, maps showing surface water bodies, maps showing locations of wells. And then if they are land applying, we're going to have a sampling and analysis plan to support whatever they're specifically doing. And we also look for compliance with the State Environmental Policy Act, usually referred to as SEPA, and that's an element of the permit process and would be a part of the permit application package. Public notice happens multiple levels, multiple times in the process. We're going to issue a notice when we go to renew the general permit. We're going to publish a notice that we intend to issue general permits, and we invite people to comment on the fact that we're going to do that. And then we draft a general permit, and probably more than one this time, and we put it out and we invite you to comment on it. And then we issue a final general permit and we tell you about that, and you're even invited to appeal that if you don't like it or you object to some aspect of it. And then each facility has to apply initially, and if they make significant changes later on, and there may be a meeting or a hearing or possibly both associated with any of these activities. There is SEPA notice associated with the State Environmental Policy Act. It's usually all rolled together. You'll see a notice that refers to both of them and tells you how you can comment and what you can do. And then with all these things, generally there's a follow-up. If you submit a comment on a permit, you'll get a response back in some format. It depends on how many people comment and what subjects they address, but your comments just don't go in a hole and disappear. The agency takes them and reviews them and then prepares some kind of response, and could in fact change a permit based on public input, information we weren't aware of. I've seen that happen. There's a lot of methods of notification. I know that everybody here reads the legal notices in a newspaper of general circulation every day, and I know that you all just want for the next issue of the State Register and read that on a regular basis, and the SEPA Register. Let's not forget that. But you know, those are legal things we do. They're not the most effective. So other things, we publish these things on the Ecology website. We send out notices by a listserv. You can just sign up and you'll get an email notice telling you what's going on. Or if there's only a few people, it might just be a direct email from one of our regional people. Physical posting of the site, and then individual direct notification. If you miss the big notice and you call up and you've still got questions, if the comment period is still open, we'll send you the information directly. Just because you missed the first notice doesn't mean you miss your right to comment, but you have to get in by the deadline. How you can be informed or involved. People have questions about that. And I would say if you're interested in the statewide general permit, and a lot of times people aren't, that's for the whole state or the statewide permits, contact me or Amber after the first of the year. We'll have better information about the schedule for how that's going to happen, and we can give you a time frame and tell you how you can get on a list to be informed at that point. A lot of times people are more interested in the facility or a specific facility closer to home. So if that's the case, then there are a range of options, way to get it. You can notify the operator in writing that you're an interested party. You can just write them a letter and say, I'm interested, and at least in theory, they're supposed to keep a list of interested parties, and they're supposed to involve you and notify you when they have a permit action that qualifies for public notice. You can come to a meeting like this. We would like to get a copy from the extension folks of the attendees tonight, and that is another way that you can be notified. We pay attention to who signs into public hearings and meetings. You can just call Amber and say, I'm interested, and we'll put you on a list. You can wait till after a general permit comes out and say, now I'm interested, we'll sign you up. And we're considering, what I really like, we're looking at, is a web-based interested parties app where you could just go online, click, put in your name and email, and you'll get notified if you're interested in projects in Island County or Asotin County. You just pick and you'll get a notice. And that would save everybody a lot of time and work, I think, my opinion. So looking ahead, we plan to split up the general permit most likely. As I said, we have one statewide general permit for all the activities. It's very efficient, but there are some issues that people don't like with it. So we're going to probably break that out into a permit that deals with just septic management facilities. And I want to say, just so I don't mislead people, that probably wouldn't apply to the Coopville facility. When we talk about septic management, we're talking about something that does only septic. Once biosolids from a wastewater treatment plant, even a small one, is mixed in there, because of federal rules, there is a different hierarchy of criteria that apply to that operation then. So when we say septic management facilities, we're usually talking about a pumper who has maybe a lagoon or a site, and that's all they do is they get septic in and they apply septic to the land. We may address facilities that only store biosolids in a lagoon because they sit there for 10 or 15 years and we don't need to put them through a lot of process right now. Or those that only send it someplace else for more treatment. Again, we don't need to drag them through a big permit process. Maybe incineration, maybe a category of facilities we call beneficial use facilities. But new notices of intent will be due from Treatment Works early in 2020. That's why I said call back after the first part of the year. We'll have a better picture of what's going on. We may have multiple draft permits. They're due later in 2020, and that process honestly could be delayed. We have a shortage of economists at the Department of Ecology right now, and we do have to do an economic analysis. And their schedule is awful. I mean, it's just 2 or 3 years out. So you kind of have to get in the line and then watch for an opportunity and jump in when you have a chance. But if it's delayed, the current permit and everything still stays in force and in effect. And then final permits would be due, or applications actually, that should say, not earlier than September of 2020. So we have about a year now still before the new applications are due, assuming we get the new permits out. So that's all I had. I know I kind of ran through that, but I think these other folks have stuff that you're going to be a lot more interested in, and I'll be around for questions later. I don't know if anybody has any questions or how many you want to field, but I'm just going to turn it back over to Sarah. And
so we may have 1 or 2 questions for Kyle. Yes?
Did you define that last category? You said special treatments?
was it up here on the screen?
Yeah.
Okay, let me back up.
Yeah, beneficial.
Okay, so a beneficial use facility in the federal system, the only people that get permits are wastewater treatment plants. And in Washington State, we went rogue a little bit quite a few years ago, and we said, well, you know what? We could issue permits to operations that are land application sites, and they could raise their hand and say, we have land and we have a permit and we have the ability to manage your biosolids. And EPA wouldn't do that. We do that, not so much for individual treatment works. And individual treatment works could have a site, but when we're talking about beneficial use facilities, Andy could talk to you about those, but we have a facility called Boulder Park in eastern Washington. It's a collection of farmers with many, many acres. We have one called Natural Selection Farms. There's some up in Whatcom County, but they are land application sites that are not wastewater treatment facilities, and their whole business is to take biosolids from generators and land apply it.
Do they get paid for that?
Yes, they do. Oh yes, they do, definitely. And that's not, we don't control how much they charge. They generally charge something per gallon or per dry ton of material delivered there.
So when one municipality needs for whatever reason to shift their biosolids somewhere else, they might shift it to a beneficial use facility? Is that? Well,
it's just a lot of biosolids management is a deceptively complex and difficult subject, and a lot of small, even to medium-sized treatment works, they don't really have the staff to be farmers, to manage a site, land application site. It's oftentimes easier for them to contract, to partner with somebody who understands farming and does something with the land and the soil on a daily basis, who has the equipment and the information and the connections to do that. So it makes sense for them to have that site. It's a service provider basically. And because it'd be really difficult for a really small community. Coopville's a little bigger, but it'd be difficult for a lot of small communities to do that. They just don't have the ability.
One more question?
Okay, I'm going to let more interesting people talk.
Okay. So, Andy,
Oh, yeah. They don't want to. Apparently, they don't want me making any untoward remarks up here that get caught on the microphone. So, that would be really unfortunate. Don't take this personally, Andy.
I don't think it's there it is. There you go, perfect. What am I doing here?
You're just talking so that you can hear you on the camera. Say something.
Cough for a while, blow out his ears. Excuse me. 1, 2, 3. Okay. So we're using this
in the
or
audience
this?
able to hear?
Speak up. I will speak up. I've never been known to be a shallow speaker. So I'm Andy Berry. I work for Washington State University. I'm a soil scientist, and I do research into and educational programming into biosolids, composting, compost usage, nutrient management, organic nutrient management, compost use, and a few other topics I've sometimes delve into over the years. But today I'm going to talk about biosolids. You'll see some recurring themes from Kyle's presentation to mine. Biosolids are a product of municipal wastewater treatment that is raw sewage solids are processed to meet EPA guidelines, yada, 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 but they need to meet EPA guidelines before they can be considered biosolids. So if you're not meeting those guidelines, then you're not biosolids, and you're a different kind of material. So plant nutrients. These are plant essential nutrients for plants, and we have macronutrients, which are on this side. We have micronutrients, which are on this side. We have some that are different colors. Nitrogen is the most one required for the amounts for plant growth. Less so than phosphorus, potassium, calcium. But these are all macronutrients needed in larger amounts, where these are micronutrients and required in lesser amounts. I have boron colored because it reminds me that frequently boron is deficient in western Washington, so it can be used as a fertilizer, but it's not so much in eastern Washington. So here are some usual ranges for what you find in biosolids. And these are ranges, they're EPA numbers from 2010 publication. And you can see nitrogen somewhere between 3 and 8%. And then phosphorus somewhere between 1.5 and 3.5%, and the rest of these are much smaller amounts. These are sometimes referred to also in milligrams per kilogram, and then you just multiply by 10,000 to get the numbers. But you can see they also have a fair amount of organic matter in them. When organic matter is beneficial for soils and for crop growth. So today I'm going to be talking about pathogens, trace elements, and nitrogen. So we have Class B and Class A, and Class B is processed less than Class A. Class A is nearly complete removal, and these are used for around home and urban situations. So those would be composts or pelleted products, both Class A materials, where the other ones would be Class B, usually a cake or a liquid, depending on what the solids removal is.
We have some here for you.
Oh, joy.
I was going to say, we do have the city of Oak Harbor here, and they produce a Class A biosolid. So if anyone would like to see what that looks like,
Okay.
we will have that
Well, I don't.
up here.
Very nice.
It's
It's a pellet material. I mean, I can open it up, but I mean, it's fine with me. But But we can look at that one later. Okay, so there's a number of types of biosolids. We have what we refer to as cake, which this is hot stuff, generally not available to the public. It's somewhere between 20 and 30% solids usually, depending on the material. And when they refer to as cake, so if you're going to get a birthday cake, maybe not a little different we want. Generally, the public doesn't get this. This is what goes on agricultural land. And it looks like, when you have big piles of it, it looks like chocolate pudding is basically what it looks like. And it'll slump to its own level. Then we move into some of these other materials. This is a Sangro material out of Pierce County. It's a pelleted material, so just like a dry granular fertilizer, almost 100% dry. We have blends, this is a Tacoma product. They make a Class A cake. They're one of the few people in the nation that are able to do a cake that's Class A. And they blend with wood products and other organic matter and sand to make a Class A blend. And then there's composting, and that's usually mixed with biosolids, can be mixed with yard debris, wood waste, or some other materials, and then composted and used basically as any other compost would be used.
Andy, there's a laser pointer on that dealer if you want to use it.
No, I like walking around. Okay, trace elements. We're going to move into the world of trace elements. And we have to remember that a number of the trace elements in biosolids are plant essential nutrients. So they're very, very important. Levels over the last 20 years have declined, and that's through industrial pretreatment programs and pH adjustments. And also, one of the beauties of biosolids, the matrix that it's made up into really reduces metal availability in the soil. So when you put biosolids in the soil, actually you'll see less available metals than are trace elements from your biosolids. And they're actually used in sites for remediation. You go to some of the really nasty mining sites that have been just ripped over, that nothing grows on it. You can apply biosolids, plant crops, and things will grow again with the help of biosolids. So here's the different levels that Kyle talked about. We have what is referred to as ceiling levels, or table 1 levels, and table 3 levels. These are higher than the table 3 exceptional values. These are, anything under these are perfectly safe to use, no problem. These are just a better quality material. This column here is just the national average. And then just for a example, here's Renton King County facility and what their numbers have been. So they all meet these guidelines for either Class A or Class B, depending on what kind of material you're making. When you put it in permit, you can provide some of the trace elements analysis for your materials, and so I had Kyle's group pull out a bunch of these for various plants, just sort of show an example. And I picked lead as an example of a number of these. They all look very, very similar. And we have a number of treatment plants here. We have red, which is one of the Seattle's Renton South plant facilities. Then green, which is a West Point facility. And then purple, which is the Tacoma facility. We have Orville, which is a small community. And then we have, where did we go to? We went to Coopville down here, and then we have Island County here. You can see they generally, here's the table 1 and table 3 values. They're all under these without any problem. They all meet specs. They do bounce around a little bit, but that can be typical of them. Sometimes they'd be looked at. You might be, in retrospect, a second looked at them, but they all look very good.
What was the spike in Island County? Just noise.
Yeah, it does sometimes go up there, and that's, I said, sometimes they go bounce around a little bit. They're still well below the table values, and in retrospect, we probably should have gone back and looked at these, but...
Well, can I respond to that?
Yes, you can respond to that one.
We debated, but we said, show the people what the data show. That's what the data show. We just don't know that far back. But probably, if I were the coordinator in that case, I would have called them up and said, what's going on? A lot of times that's a lab error, that they've done some math wrong or something.
Right.
And it's still within numbers, but you're right. When you see a spike like that, you want to ask a question.
Right. So we're going to talk about sort of the land application, nutrient management things for the agronomic rate. When you're applying biosolids for crop production, it needs to be applied at agronomic rate. And nitrogen is the key nutrient for determining application rates. So nitrogen actually comes in a number of different forms. I'm going to sort of walk you through this. We have, first is, we have organic fraction of the material that comes from either manure, biosolids, plant residues, soil organic matter, and that's at the top of the cycle. We have organic N, and then we go through a two-step mineralization process from organic N to ammonium N, which is plant available, and nitrate N, which is plant available. And these can be used for either plants or microbes to grow. And then you can also, nitrate can be available for leaching, or it can be, again, changed into N2O or nitrous oxide and go lost to the atmosphere. But this is very, very important for determining application rates, not just on biosolids, but also on manures and composts and other organic materials. So this is just a sort of the thinking about, walk through nitrogen availability. This is year one, and we have the purple part, which is plant available. And then we have the residual soil N, which is going to be in the organic framework, which will be there. So the first year you get this available, and then this is carried over for the second year. So in the second year, if you'd made another addition, you get the same amount you would in the first year, but you also get a smaller amount of this fraction becomes available in the second year. And then the third year, you get, if you apply again, you get the same amount you get in the first year, plus what you got in the second year, plus a little bit in the third year. And that just keeps growing as you go on. So that's why when Kyle said you determine what's going on in the soil, part of this is we know what we're applying the first year, but what went on for 3 or 4 years later has to be taken into account for nutrient management. And this is the nutrient levels for determining organic N availability. Depending on your processing type, you're somewhere between 0 and 40% available. And then for the ammonium, we're looking at 20 to 100% retained, depending on how it's applied. Organic, the second year, 8% available. And nitrogen for the third year, 3%. For the fourth and fifth year, 1%. So it really stomps down from the very first years into other years, smaller amounts every years. And this is just showing, demonstrating beneficial use. This is when we use the compost. This is the growth using the biosolids compost. This is without any fertilizer at all. It's just demonstrating less growth. So the other nutrient that you get, it's not a regulated nutrient, but it's an important one to look at. And I would say, just not in the world of biosolids, should you be looking at phosphorus. Any farmer or backyard homeowner that's growing vegetables or fruit and flowers should be looking at their phosphorus numbers. You're getting a fair amount of phosphorus from biosolids, and it provides long-term benefits for crop growth. But you need to be very careful not to avoid too much loss of P into the system, because it can be, given the right conditions, it can lead to over-application and runoff from your fields. During the application period and land application, there's buffers that are used to avoid that. I'm going to slide a little further on, showing the lack of movement of phosphorus in the system. And there's a number of different tests that can be used to determine the risk of phosphorus movement into a nearby waterway. There's tests that you use for determining plant availability, and a different set of tests to use for determining potential risk from runoff. Potassium. Biosolids contains very little potassium, and if you're growing crops with biosolids as your only nutrient source, you're going to need to think about your potassium levels and add potassium if necessary from a commercial fertilizer. But it definitely needs to look at. So we've got a number of extension bulletins out there on biosolids, and there's one that basically walks you through every step of calculating biosolids application rates there are, and it works very, very well. We're going to go into that a little. So some of the information that's needed is the nitrogen concentration of the biosolids, other sources of N, particularly if you're growing grass. Are there going to be cows involved? Has manure been applied in the last few years? Are you applying any fertilizer at the same time? Soil factors need to be taken into account. What kind of how much N availability you may get from the soil. If you're irrigating, what kind, are you getting any nitrogen or phosphorus or not potassium, but nitrogen particularly from the irrigation water needs to be taken into account. Previous applications. And these are all used and to determine a recommendation for biosolids application. And usually I recommend using extension bulletin if there's an extension bulletin for determining application rates, or you can go to a soil scientist that's familiar with the various crops you're growing and use their professional judgment. There's two that are used mainly in Washington, which would be this top one, which is a pasture management one. It's brand new in the last year. It's replaced the older one. It works very, very well. And then a lot of biosolids are applied to dryland wheat, which is used, and this is the other bulletin that's used for dryland wheat situations. Okay, so we're going to hold off on the research. And Georgine, I think you're going to come up.
So while Georgine gets set up, do you have any questions for Andy? Anybody have any questions?
The question to answer.
I'll try to, yes.
So the ceiling limit for those 9 heavy metals, is there any requirement to monitor that year after year on the application site itself?
Not that I know of, Kyle. Yeah, go ahead and answer, Kyle.
So
That's a regulatory. Sorry.
the question was whether there is a requirement to monitor, I assume you're talking about accumulation of metals in the soil over a period of years. The answer is yes and no in a typical government fashion. If you are above the table 3, that lower level, if you are above table 3, the lower level, and below that ceiling limit, you do have to monitor the cumulative loading of metals for the life of the site. If you are below that table 3, you do not have to. And I wouldn't do it here, but I could show you some math that would illustrate why it just takes literally hundreds of years or thousands of years to accumulate enough in the soil to be of significance. But EPA wants people to be better than that ceiling limit, so there's kind of a penalty, if you will, for applying material in that range.
Andy, you can explain why nitrogen and phosphorus loading was a problem. But you made it sound like it was a problem.
It's a potential problem if you put on too much. Because for nitrate, you get nitrate leaching into the groundwater, and you can do detriment to your groundwater that you're using for various other sources. And for phosphorus, you potentially run the chance of runoff from your field. So they're both, both of them you really want to avoid, which is why you really want to go with agronomic rate.
Speaking of the phosphorus runoff, is that kind of what we're seeing up in Bellingham when we have this dead zone in the benthic organisms in the bay?
I have no idea. It's not my area that I'm dealing
I
with.
think it would be more, I mean, yeah, phosphorus doesn't cause the algae blooms in salt water. Phosphorus can cause algae blooms in fresh water, but in salt water, it's nitrogen usually.
There is treatments, and DOE is actually starting another general permit for nutrient removal and treat sound. So there's a whole website on that that will be on what we talked about today.
So I know you talked about monitoring soil levels of various minerals and nutrients, and then adjusting your application rates accordingly. Do you monitor underlying groundwater levels and take those into account?
The question was about monitoring metals in soil and groundwater. There are pre samples that are taken beforehand. Kyle, I'm going to let you handle the afterwards.
Okay, so if you're starting with a site for the first time, then we will ask the operator to take samples of the soil to look for metals to make sure that we don't have a site. For example, I do recall one site that I worked with in eastern Washington. When they sampled, they found very high levels of lead and arsenic in the soil associated with old lead arsenate pesticides that were used in the orchard business many years before. And they said, no, we don't need to be there because we don't need to be tied up with that problem. So we asked them to look for that. We don't look for metals henceforth after that unless they're high, and we just don't have any of that in Washington. As far as groundwater metals go, No, because they really don't move. They're not mobile from the biosolids. Nitrate definitely is mobile. We focus on the agronomic rate. So if we have the agronomic rate, we don't need to worry about the groundwater, but we also follow up every fall with what's called a post-harvest report card nitrate sampling. We look at the residual nitrate in the soil to see if the application has been on target. And if it's been on target, great. If it isn't, then we can make adjustments the following year. We're really not worried about 1 or 2 years of, nitrate being a little high. What we're worried about is a long-term pattern of excessive amounts of nitrate. So as long as we watch that year to year, we're okay. And we don't require groundwater monitoring at biosolids land application sites.
One more question? We're good? Okay, thank you, Andy. So Georgine will address the emerging contaminants that might be of concern.
All right, and I do sometimes have trouble speaking loudly enough, so if you can't hear me in the back, just raise your hand and I will try and speak up. I'm going to talk a little bit about emerging contaminants of potential concern, and first I just want to explain what it is that I mean by that and what's the question that's being asked. And essentially, when that emerging tag means I'm not talking about the 9 regulated, the heavy metals and other elements that are regulated, right? Those are not emerging because we know and we have ways of making sure that we're not at levels that are going to be of concern. And I put potential concern because really the question we're asking here is, are there things in biosolids that could cause harm to either humans or the environment? I want to go back. Actually, I'm not sure anybody else showed a slide like this, but just thinking, right, we've got, in terms of how we get biosolids that might be land applied, we've got wastewater inflow. And remember what Kyle was saying, so how do things that are emerging contaminants end up in biosolids? They come in our wastewater. They're products that we come in contact with in our daily lives that we're already exposed to, and through various ways they end up in our wastewater. The second thing I want you to notice on this slide is just this wastewater processing step. And the wastewater processing steps really vary from facility to facility, and I'm sure Kyle could tell you a lot more about that, but there's usually multiple different processing steps in a sequence, one after the other. And depending on what those processing steps are, so first we ask the question, are there potential contaminants or materials of concern in the inflow? When we process them, are they going to make it through those processing steps, or are they going to be degraded during or changed during that processing step? And then lastly, if they survive that wastewater processing step, we're thinking about, and then they're land applied, is that going to cause a potential harm either to human health or the environment? So that's really the question that's being asked. And we're talking about a pretty wide variety of potential materials, everything from sort of viruses and bacteria to household and industrial products to pharmaceuticals. But again, all materials that we come into contact with in our daily lives. This slide, I'm really just trying to make the point here that this is an active area of research, and it has been for quite some time, I would say at least 30 years, that researchers have both, I would say most actively in the US and Europe, a little bit elsewhere in the world also, have been asking questions. So both, kind of review studies to say, as a whole, what do we know about this topic? Can we assess what the risk is? And then individual studies on particular potential contaminants. A couple of points I want to make about this. The first is that I think this literature is best seen as kind of a subset of a much bigger literature that asks the question about these products, not only in biosolids, but also in the rest of our lives. Where do people come into contact with potential contaminants that can cause harm to human health? And I guess I would say two things then. One, when we look at this literature over the last 30 years, we do not see examples where emerging contaminants have been shown to cause harm to human health or the environment. is still an ongoing area of research. We continue to look at this question. There continue to be new sort of compounds and materials invented that haven't been looked at before. And then the other point that I want to make here, and this comes back to this is part of a broader area of literature, is that we do not see examples where biosolids are the primary pathway of exposure, right? There are lots of other ways that we're exposed to these materials. This slide really comes to the question of, there are a lot of things that potentially could cause problems and that people have looked at. So I think it's helpful to think about those materials as being on a continuum from, very low risk on the one end to high risk on the other end. And so I think it's helpful to think about what are the factors that either reduce the potential risk and would, put you on that side of the continuum, versus what are the factors that increase the potential risk and make it more important to really ask that question of, is there a potential for harm? So factors that reduce the potential risk are materials that degrade in the environment, materials that are bound tightly up in soils that keeps them from moving elsewhere, also makes it difficult for organisms to interact with them because they're tightly bound with soil particles. Materials that have low toxicity for humans and the environment, and materials that do not bioaccumulate, meaning they're not concentrated in biological organisms. On the other side, factors that increase the potential risk, things that are persistent in the environment, where there's evidence of human or environmental toxicity, or there's evidence of bioaccumulation. And again, I just want to remind you that when we talked about those regulated metals and other elements, it's because, or part of the reason they're regulated is they have those features. I'll talk briefly about kind of 3 big categories of emerging contaminants that people have looked at. The first of those is pathogens, including bacteria and viruses. Kyle made the point that they're, everywhere in our natural environment and encountered commonly by the human body. But they do include disease-causing organisms like bacteria and viruses. When we're thinking about potential disease-causing organisms, one subcategory that we can think about is those that are involved in terms of food safety risk. And I just want to say a couple things. First of all, those when we're thinking about agricultural systems, those organisms can come in through a variety of different mechanisms. So through irrigation water, through birds and deer that are that sort of roam through agricultural lands. And the way that our structure deals with that is through sort of good agricultural practices that try to minimize the risk and identify those. And I guess, I'll stop there. Talk a little bit about pharmaceuticals. These are obviously materials that we purposely ingest in our bodies, and some amount of them are not metabolized in our bodies and therefore end up in wastewater. Among the different types of pharmaceuticals that end up in wastewater, some amount of those are degraded during wastewater processing. Some of them are not. Some of them also degrade in the environment after land application. And then a few of them are more persistent. Among pharmaceuticals, one category that people have looked at quite a lot is antibiotics. And the reason that people have asked a question about antibiotics has to do with, okay, if we're putting antibiotics into the environment, does that have a potential to add to the development or increase the risk of development of antibiotic resistance? And the short answer is we don't see that from biosolids land application. So we see that antibiotics do not accumulate in the environment over time. We also see that antibiotics at the concentrations that are applied in biosolids, we don't see impacts on soil microbial life when people have looked at that question. We also do not see different levels of antibiotic resistance in microbial life in soils that receive biosolids if you compare that to soils that have not received biosolids, or soils that have been fertilized with chemical fertilizers. So they all have sort of the same levels of antibiotic resistance in the soils. And then the last category I'll talk a tiny bit about is industrial and household chemicals. This, again, a category with a huge variety of things in it. One question I just think is worth, that helps frame, how do you think about this incredible complexity, is to think about the question of what are exposures from biosolids compared to other pathways that we might be exposed to these kinds of compounds. And so this table here is looking at the median concentration by weight in biosolids versus household dust. And obviously, household dust being something that most of us are exposed to much more often than to biosolids. So you can see here the one place that we're sort of an order of 10 higher in concentration in biosolids than in household dust is this triclosan. This is antibacterial. But I do want to make the point that that is the active ingredient in an antibacterial hand soap. And so if you wash your hands once, they estimate that the exposure is 1,000 milligrams per kilogram. So some concluding ideas. I think this will sort of reiterate some points that I hope I've made along the way. But exploring potential contaminants in biosolids is an ongoing area of research, both in the U.S. and internationally. It relates to biosolids. It also relates to other potential materials or aspects of our environment. Research to date has mostly identified low risk from non-metal contaminants resulting from land application of biosolids. And then among those, the many compounds that are found in biosolids, those that are more likely to be problematic for human and environmental health, meaning those that probably are worth continued study, are those that are present in biosolids at high concentrations, those that are persistent in the environment, bioaccumulate, and have negative human or environmental impacts. So I think that's just a way to kind of think about which ones merit further attention versus which ones less so. And then in those cases, really evaluating the total exposure, both from biosolids, land application, but also other potential pathways through which humans and the environment are exposed, is likely to be pretty important. And then I do have some two pieces of additional reading for those who want more. This is a WSU peer-reviewed extension bulletin that talks in more detail about emerging contaminants. And then I think many people picked up this, if you want something sort of short and easily digestible, this short flyer from Northwest Biosolids may be of interest. Sarah, do you want to go ahead?
So a few questions, go ahead.
Thank you. If you were to sort of list your top 2 or 3 persistent pharmaceuticals, or just even your top persistent one that comes up in research that you've seen, I'd be interested in that. Follow up to that is hormones, and particularly endocrine disruptors as it relates to amphibian population. Can you speak to that a little bit?
So I could speak a little bit to both. So the first question was about top pharmaceuticals that are persistent that we see mentioned in the literature. The top one that I have seen mentioned, again, in these kind of reviews of risk is, I think it's carabamazide, but I would have to double check that it's a drug that's used, I think, to treat psychosis, among other things.
It's a lithium-based drug.
And then in terms of endocrine disruptors, I guess the thing I would come back to is that we see that's one where the pathways of exposure, I think, through other avenues than biosolids are probably high. So again, although I'm not an aquatic ecologist, there's some sense that they may have negative environmental impacts. But
Georgina, can you reflect on the quality of the materials that are being put into biosolids category here in Island County?
I can't because I'm not here. So I guess Sarah, do you want to say anything about what's going into biosolids here? It might be a question for the.
I could adequately answer that question.
I guess they would. I mean, they have to have a permit, so they're going to be tested for those 9
Can I address that?
metals.
I'm with the City of Oak Harbor, and we do biosolids and test it. You gotta remember, Island County is mostly a rural area, and so we deal with what we call mostly a domestic waste, where you start dealing with some more of the exotic metals and chemicals. It actually comes from industrial sources, so we don't have the industrial base here to that. So our pathways for that type of stuff is a lot less. We monitor it. Part of our permit requirement for the wastewater treatment plant, which is outside this general biosolids, is monitoring for those toxics coming into the site. So generally, we're considered pretty innocuous compared to a city that has a lot of industry.
I think it goes back partially to what Georgine said. What ends up in our biosolids is what we have ourselves put there. So rather than any major industry that's going on that's putting materials into the wastewater, it comes from each of our homes for the most part.
Could I add one other point here? I think one other thing worth noting, just not specific necessarily to Island County, but the state of Washington has a pretty aggressive, what we call a pre-treatment program implemented by our water quality people. So when they identify an industry with a significant discharge to a sewerage system, they go back to that industry and they require them to treat their wastewater before it goes into the sewers so that they can't be discharging high levels of contaminants. And if they identify a new substance that needs to be regulated, that's where they will go back to the source so that we get at these things at the front end instead of at the back end. So that's an important aspect of the state program.
Basically, they have what I refer to as sewer sniffers. They actually go into the line and can collect samples coming down the sewer line so they can identify where the stuff's coming from.
But not in Island County.
No, not in Island County.
Oak Harbor doesn't have any industrial users.
We do have, not to interrupt here, but we do have the naval, the.
Naval base does
naval
not,
base.
it discharges into their own treatment plant and into the lagoon.
But answer my question if you could, because I'm confused about this, because there is some groundwater around that area that's contaminated.
That has to do with firefighting chemicals
Right.
that were sprayed on the grounds. That had nothing to do with the wastewater treatment plants or that. So it was their firefighting practices.
Same thing.
But would we,
So if the wells are contaminated and that wastewater ends up at Coopville, would it be appropriate to even test for PFAS in biosolids?
We actually test for PFAS in our influent.
so.
And the
The
Harbor
city
and
of Harbor.
Coopville are different facilities though, right?
Right.
And you guys do Class A, but Coopville does not?
So we test for PFAS before it ever gets, remember the biosolids are a result, a residual of our treatment process. If it doesn't get into the plant, it doesn't get into biosolids.
But yours is a whole different system than the county is using, correct?
Okay,
I just wanna know, right? So you're totally different? Okay.
let's hold on the PFAS for a moment, and just a quick on Don's question, that also might be something that you could ask to the solid waste manager as well. Question here.
Yeah, aside from, I know you mentioned that they were triclosans, I don't know how to say it right, but, aside from that, what is the other, is there any other main chemical that does come up a lot, that's not pharmaceutical, but just environmentally found in our stuff today?
Not, I guess, again, it comes back to not at concentrations that are high enough to be of concern, that are persistent in the environment, that make it through the processing, and for which biosolids is the primary exposure pathway. So, this comes back to that question you asked about endocrine disruptors in our environment. I think people are asking questions about that. but that goes way beyond biosolids in terms of where we're exposed to those compounds and how they end up in the environment, frankly, as well.
Okay, I think we're gonna pause there, and, one
Yes,
of
we're
you,
gonna go back to Andy.
we're gonna go back to Andy and look a little bit at current research, and go from there. And then at the end, we'll have some time for more questions.
Okay, voila, we're going to talk about some biosolids research. I've been with WSU 30 years, and I've been working on biosolids for about 30 years. Actually, I lied, 29 years. But it's the same as my wedding anniversary. But there's two studies we're going to talk about today. One is in Eastern Washington, one is Western Washington. So we're going to start with the Eastern Washington one first. You see that? Okay. So we have, in the first experiment, which is refers to as the Long-Term Biosolids Research Site, or sometimes referred to as GP17. It's known throughout the nation as GP17. We have 3 different rates of biosolids, 2, 3, 4.5 dry tons of biosolids applied per acre, an unfertilized plot, and a fertilized plot. Fertilized plot receives 50 pounds of biosolids every time there's a crop, where biosolids is applied on an every 4-year basis or every other crop. It was replicated 3 times. Each plot is about an acre in size. So that's about 50 feet wide and about 700 feet long. First crop of biosolids was harvested in 1996, and it was grown to soft white winter wheat, and soft white winter wheat was grown for about the first 20 years on this project, and then we switched to some other crops that are used. And generally, they follow a crop fallow situation, so they have a crop 1 year, they have no crop the next year, and they're storing water into the system, and then they'll come back the year after that and grow another crop. So here's the yield from the very first year that biosolids were applied. We have the blacks, the unfertilized, red is fertilized, and then 3 rates of biosolids. And you can see that all rates of biosolids are statistically significant, which means they're statistically have greater yield than either the fertilized or the unfertilized control. We talked earlier about agronomic rate. Agronomic rate on this study is about 2.5 dry tons per acre. I want to be able to have it bracket agronomic rate so we can have something a little higher and a little lower, so we know we're right in the sweet spot for where we need to be. And this is what yield looked like over the number of years. The interesting thing about this site, it's a fairly dry site. It's 8 to 10 inch rainfall in a year, and so you have a couple of cycles going on here. You have the first year biosolids were applied. Generally, there's less nitrogen available in the second year, so it's lower, and it alternates back and forth like that, sort of, because we have rain that supersedes this, which also causes some fluctuation. So you can see here we have some rain effect in that year. And then this year, this was really dry, so yield's not very good at all. But that's typically what you find. And biosolids is either equal to or greater than commercial fertilizer use for growing dryland wheat. So there are questions about phosphorus. This is a little bit about phosphorus on this site. Phosphorus is usually deficient on this site. And what we have here is we have a biosolid site, and then we measured phosphorus. We measured phosphorus across the slope, so we started uphill here, and then we went downhill into a site that had no biosolids, so any phosphorus that ended up here would have come from biosolids moving over this way. And you can see that from here, you get a little bit of movement, but then after about 10 feet different, about 20 feet difference, you get it baselines off from the phosphorus. So you're really not getting
movement of phosphorus at all on this site.
How steep is that hill?
4% slope, 5.5% slope, and 0.4.
Okay. Oh, there it is.
Yeah. So this is just a few of the other things we look at. We look at total C, or total carbon. This relates to organic matter. And again, when you're using biosolids, you have an increase in organic matter in your soil, which is good. Organic matter helps soil health. And then for total nitrogen, which is also increased through the use of biosolids, which works very, very well. If you're looking at soil health or soil quality, the first test that I'd like to look at is bulk density, its relationship of how weight to volume in the soil. So the lower the number, the better. And so in this case, we have the commercial fertilizer and unfertilized is a harder soil than the ones with biosolids that become softer or have a lower value. pH, because we have pH issues in eastern Washington. When you use fertilizer, you get a depression in pH, which we see here. You can see a similar depression of pH from applying biosolids. Okay, so that's the summary of the dryland ag site that we're using. It's been a very successful site. We've been there since about 1994 was the first application, and then the first harvest was in 96. And we've so far showed very good health benefits. There's been a nationwide program to look at soil health throughout North America, and there's about 100 different sites that have been chosen. This site has been chosen as part of that analysis, so you'll be seeing more information in the future about soil health, just not in Washington, but across the country, across the state, and they're going to be looking at this site as how it compares to some of the other sites they're looking at. So the second study is looking at a western Washington site. We're growing tall fescue. It was planted in 1993. Like the other study, it has a few rates of biosolids, 3, 6, and 9 dry tons per acre of biosolids, unfertilized control and a fertilized control. Fertilizer control is 300 pounds of N per acre. And then we have our split application, so we apply biosolids 3 times during the season, once 30 days before the first harvest, and then after the first harvest and the second harvest. And biosolids were applied until 2002, and it's an irrigated site. This just shows these pictures here. This shows we have a little plot harvester. This is the length of the plot, and we're able to harvest the plot. We weigh it and then put it in the spreader. And this is a colleague of mine, Dan Sullivan, spreading some biosolids on a research plot. Okay, forage yield. This looks at every year since we started this. We stopped playing biosolids in 2002. We have a number of treatments here. We have forage yield on this axis, and we have the gray numbers here are 0N, no nitrogen applied. And then we have fertilized nitrogen. And then we have 3 rates of biosolids. You can see in most cases the biosolids out yield the commercial fertilizer. But we mentioned earlier they're looking at a post-harvest nitrate test after harvest. That's what I have here. Shows post-harvest nitrate for the different treatments. You can see they all cluster fairly closely except for this one, which is the highest rate of biosolids. Agronomic rate on this trial is about this middle rate. That's usually how we try to find things where you can see on the middle rate. Generally, these they're all about the same. Critical range for this test is in that 20 pounds per acre. So this looks at soil carbon, because soil carbon is important for carbon sequestration, climate change, and we can see here that we have carbon in different ranges. We have the 0 to 3 inch range, 3 to 6 inch range, 6 to 12 inch range. You can see that the biosolids basically store more carbon than the fertilized controls in the top range of the soil, and then in the 3 to 6 inch range you get a little more than the fertilized. The others And then the other one, it starts to get a little noisy, but still showing more carbon.
What do you mean by the inches that you're talking about on across the bottom?
This is 0 to 3. So when we sample, you push a probe into the ground, and that top is 0 to 3, then 3 to 6,
Okay.
then 6 to 12. So summary, biosolids is a good source of nutrients for crop production, both in wheat and grass pasture. Repeated application can lead to an increase in phosphorus levels, so that needs to be taken a look at to make sure we're doing okay on our phosphorus levels. If managed properly, that's not an issue. The use of biosolids can increase soil carbon or soil organic matter in your soil and available nitrogen. And using biosolids can improve soil health through reduced bulk density. And here are a few publications that are available. Fertilizing with biosolids was on the front counter. I mentioned this one earlier, the worksheet for calculating application rates. This one is specific to dryland cropping systems and biosolids. And then the guide to biosolids quality is the one that Georgine mentioned. And there's my contact information.
In your studies, or pictures you're showing, was that Class A or Class B that were used for?
This study is actually Class A material. There were two different materials. One
Does
is
that
from
make a big difference?
from nitrogen availability standpoint.
Yeah, for all that kind of stuff.
No, because the grass site was a Class A site. Two different Class A materials. One was a Class A cake, and one was a dry product. And then this GP17 is a Class B traditional cake material.
So most of this is focused on biosolids around concentrated concentrated processing facilities. Some of us on smaller farms and on the south end where it's septic dominated have interest in advanced composting toilets and those types of things. Is there crossover research in the more distributed model of processing and application on site currently underway in any of these programs?
I've occasionally seen papers in composting toilets, but not a lot. It's not an area that I really focus on.
And one quick follow-up that's related is aerobic versus anaerobic digestion. Again, we're septic dominated on the south end, have a lot of leaky septics. Advantages to aerobically processing these materials for bioavailability and also processing some of the pathogens.
Question was on availability of products between anaerobic and aerobic processing. And I don't see a difference from a nutrient availability standpoint. It really has to do more with the differences, not so much between anaerobic and aerobic for application rates, but lagoon materials or a dry product. Then the nitrogen dynamics changes a little bit, but all very similar.
Could you tell us more about the application of the biosolids? Does it make a difference how it's applied, and what happens? What do they do with it after immediately after it was applied? Is it just left to lie there, or?
Well, if you're depending on where you're applying and how you're applying it, if you want to meet the vector attraction reduction, then you can apply on it. You have to, if you're doing a Class B, you have to keep people away for, I believe it's 30 days, and keep them separated out from that. The question was about timing and how long you need to stay off. In some places, depending on what you're doing, some places inject biosolids into the ground, which means you're not going to lose as much ammonium as you would if you're land applying it, surface applying it.
On your slide, you were talking about the carbon sequestration at various depths in inches. Were the plots that you were using, were those plots that were plowed on a regular basis or just left in their natural state?
These were grass pasture plots, so they were planted in 1993, haven't been plowed since.
Where was this?
The grass plots are in Puyallup. The dryland wheat sites are in Douglas County.
Is their soil better than ours? I mean, ours is just
Well,
Ours is glacial silt and it's.
yeah, the Puyallup site is a glacial runoff. It's a Puyallup fine sandy loam, fairly, very high in sand, 3 to 5% organic matter. So I don't know what, I've never looked to see what the soil is in this area. So.
Bad.
It's a mess.
Clay.
But a Puyallup fine sandy loam soil, it's about as good as it can get for soil.
So I have, well, actually, I'll wait until we open up there.
Okay, any more specific questions for Andy on this portion?
I don't have a question, but I had to notice, now you were talking, this was all the A compound, which is the safer of the two.
No, there's 2 studies. One was a Class B study.
All right.
One was a Class A study.
Well, in either one of them, I have to tell you, I didn't see one personal residence in the background of any one of those pictures. They seem to be in an area where there's nothing around, so that nobody actually is gonna walk over it. The little poster here tells you that you can't walk over it for so many days or whatever. Humans supposedly, or we were told, a year, where it was done in a lot, 2 years ago. And it's in a residential neighborhood.
Yeah, I can't really
I know
comment
you
on,
can't, and
on,
what I'm
on,
trying
on
to
a
say is,
specific thing.
you've displayed an awful lot to us and everything else, but it doesn't particularly occur to be part of what's happening in Cooper. Yeah.
Now, Kyle might be able to address some more of the specifics versus in terms of the allowing of people to be active in areas with Class A versus Class B. But again, we're not discussing specific instances or things, I appreciate that. But at this point, why don't we let our speakers sit down and maybe we can move into.
Actually, could I stand up and walk
Sure.
around the corner for a minute?
No.
Then I'll come back and sit down.
Okay. All right, so any questions right now for Georgine or Andy? Let's start back here in the very far corner.
So I probably should have sat further forward because I couldn't really read the chart you had that had the different emerging contaminants and what you were finding in biosolids. But when you talked about the things that make things risky in biosolids, there was persistence, there was mobility, there was bioaccumulation and health impacts. Hard to come up with a better contaminant than PFAS for striking all of those. So the question is, are you guys doing any active research on PFAS and biosolids and mobility and specifically reaching to groundwater?
So,
Repeat the question, I'm getting it.
sorry, the question was, given that PFAS sort of strikes some of those notes that I was saying, lead us to think there might be more risk. Are we doing active research in this area? I will say that I do not do research in this area. I merely have done a literature review to look at what others have found. So I work mostly on agriculture and climate change and some on water-related issues. This BioSolids is related to my work in the sense that where we can recycle carbon back to landscapes, we store carbon, and then that helps both in terms of climate change mitigation and adaptation. It's sort of actually how I got interested in this question and started to look at it. That's not exactly the question you asked, so I will just say that yes, there are people looking at PFAS in biosolids, and partly the concern is also because it's partially soluble, it can move through soils like into groundwater. I think that Kyle, but this is also, this comes back to that point I made before about where are the pathways of exposure and how are people getting exposed to these materials, and I think Kyle can talk more specifically about the work at the state level to think about PFAS, not just via biosolids, but more generally in our environment. Kyle, sorry.
Kyle can do what?
Yeah, I'll take this for a minute. I do continue to do research in Washington State. I've been approached with doing some PFAS work. We haven't got started on it yet. We'll see if we can get funding for it. There's a lot of things that go on with PFAS, which is where Kyle was in for a number of these because it sort of falls into that category. But there's only a few handful of groups that are working on PFAS in the country.
So I'm not sure if I'm supposed to take questions or continue on the PFAS route, or what am I wanting to do here?
He was questioning about it getting into water, like underground water from this stuff.
So, can you choose my questionnaires for me, and then what was the?
I will do that. So,
So I see hands popping up everywhere. I don't
yeah,
know.
go ahead and get them back on
So
track.
Kyle, the question over here was, how soon after an application of A and B can you walk out on a field? That must be a regulated thing.
It is. So the question is about access to sites where biosolids are land applied. So for Class A biosolids, those are products that can be sold or given away directly to the public. In fact, in many cases, the public literally goes and picks them up. So obviously there isn't a restriction there, okay?
They're saying no.
You can open it, it gives a little whiff odor, so let's do it afterwards.
When you bottle it up like that, it kind of keeps
Yeah,
the odor,
it's-
it keeps the odor in.
It's actually,
Steer manure.
that's much.
So for Class B products then, there's a range of considerations. We talk about sites with a high potential for public exposure, those with a low potential for public exposure. And the restricted access is from 30 days to a year, depending on what's going on and how the material is being applied. It's the same thing with crops. It depends on what kind of crop you're growing, when you can harvest it, whether it's a root crop. So there's a lot of considerations, but it can be a year. What we really want to avoid is we want to avoid on a Class B site, we want to avoid somebody throwing out a blanket and having a picnic out there. It's not so much that if you walk across it, you're putting yourself at risk, but we don't want all kinds of people walking across it, because then you multiply the potential for contact with versus with one person versus 1,000 people, for example. So it's a precautionary thing. Both Class A and Class B are safe for use in the environment when you follow the label directions. And that includes restricting site access in some cases.
And that's public access, is that correct?
Right,
Like I mean, a farmer, he can walk.
Oh yeah, that's what I'm saying. The risk there isn't really very great. The farmer can go there. It's more, you can think in terms of informed access. We don't want people not knowing, going out and playing fetch with their dog and that sort of thing. But if you know what's there and you're the farmer, yes, absolutely.
We'll get a question back here in the.
So, Georgine, on that slide that you had, the various unknown chemicals that are, showing up that are being studied, BPA was listed. Is that a measurement of plastic?
Yeah,
In the
plasticizers,
biosolids?
right, I think it was DHP specifically on that table. What's it? Yeah, it's a plasticizer.
So, there's a lot of publicity about, plastic getting into the Puget Sound waters.
Right.
The fish are being exposed to the plastics. We eat the fish, so we're kind of transporting plastic through our food chain, which ends up at the wastewater treatment plant. So is plastic monitored on how much plastic is ending up in the biosolids?
Can you repeat that?
It's echoing back, so you
Sorry.
can't hear him.
This is, you want me to repeat the question?
Yeah, just summary.
The question was about plastics, and we hear about plastics in the Puget Sound and plastics then being consumed by fish and accumulating, and then we eat fish. This comes back to that question I sort of come to again and again about pathways of exposure and how are we exposed to these products. So I forget what the numbers were for DHP in that table, but there are studies, for example, when you store olive oil in a plastic bottle, you can have, many more times as much plastic in that olive oil, which is intended to be ingested by people, as you see in biosolids. So that's kind of this, I would just sort of push that holistic view of it, not to say these compounds aren't problematic, but they get into biosolids because we use them in our daily lives, right? Or they wouldn't be there in the first place.
Right.
And then thinking about how compounds become in the environment, biosolids is only one very small slice of that. So we want to think more holistically about that, where we think there might be a problem, and think about how can we limit the amount that's getting into the environment, targeting the most important pathways, most significant pathways.
A question here?
Yeah.
Well, just want to follow on. I think it's important to distinguish between what we call microplastics, minute pieces of plastic, which is kind of what you're talking about, versus some compounds that are associated with plastic, which is a little different thing. The other thing to recognize is that the microplastics that are getting into Puget Sound, they're not coming from the biosolids, they're coming from other activities. So biosolids are not the source of what you're finding in Puget Sound. So I think that was an important distinction.
Yeah.
So, Georgine, I'm sure you know of the EPA IG report. I have kind of a two-part question for you. One, the Inspector General for the EPA, studied the biosolids program. They determined that there's 352 pollutants found in biosolids across sample sizes, and 61 of those are currently designated as acutely hazardous, or priority pollutants within other programs in the EPA. So, one, do you think it's appropriate that BioSolids is not regulating any of these pollutants? And two, the BioSolids program regulates itself, so it has a mandate to biennially regulate new pollutants, and it's never done that. Do you also think that's appropriate?
So the question is one about a report from the Office of the Inspector General. It's from 2018. I'm actually going to pass this one to Kyle, who has more intimate knowledge of that than me.
Okay, so you had kind of two parts to your question. One was just in general about the Office of Inspector General's report and their remarks about there being 350 pollutants that they found in biosolids that EPA isn't regulating, and 61 of them being hazardous substances. So that was your first remark or your query about the response to that.
So there's 61 designated within other EPA programs.
Right,
So they're
okay.
regulated.
So we could have a whole meeting talking about that Office of Inspector General report, believe me. So here's the deal. In the state of Washington, we have an auditor, and they occasionally come. I've run grants before that have been audited. They come in and they look at your programs, and they're just looking to make sure that somebody isn't, taking money or doing something, abusing a state authority or something like that. But they're a separate agency. They're also a separate agency at the federal level, but the federal government is bigger, so they're fortunate to have some of these people kind of stationed right with them, looking over their shoulder, and they rotate around, and nobody knows why the Inspector General performs audits when they do. Nobody knows why they did an audit of the biosolids program this time. They just did. I've read the report multiple times, and I like to be kind toward people. I think that's probably the worst report that I've ever read put out by any auditor in my 30-plus years of government service. It is a terrible piece of work. Now, that's not to say that it doesn't have some value. They did point out some things that we have addressed EPA. EPA got mad at me for quite a while because I kept telling them, I don't like that you guys went away from the program. They put a nationwide program together. Then they said, this is a low priority. We're going to disinvest from the biosolids program, and they left the states all twisting in the wind. Very unhappy proposition to be in when you're trying to address questions that really need some national leadership. And the Inspector General rightly criticized them for that and for not transferring education and information properly, and EPA is responding to that. The arguments about hazardous waste and the pollutants you find in biosolids, that's where I really take exception to the report. You will find those same hazardous substances, many of them, under your kitchen sink, in your car, on your shelf in the garage. You paint with them. You do all kinds of things with them, but you don't eat them. So it's like somebody saying, well, the standard for lead in biosolids is this high, and in drinking water it's way down here. Well, okay, you don't drink biosolids. So everything has to be taken in context. Presence does not equal hazard. You can't, just because you have something does not mean that it's a hazard to your health. It's all about the route of exposure, the susceptibility of the host, the form of the material. There's a lot of factors that go into determining a risk. The Inspector General didn't really highlight that, and they really sensationalized these points. These things that they're identifying, yeah, they're worth looking at. And I have said for many years consistently, science shouldn't rest on its laurels. Complacency and science, good science, are mutually exclusive. We should be doing research. We should be looking at these things, because if we don't, then we get caught flat-footed. That's not a good thing. So we should be looking at it. But the Inspector General's treatment of this subject and their presentation report, they had people who asked to talk to them about their report while it was being developed. EPA begged them to please talk to us because you got this wrong. They wouldn't talk to EPA staff. Outside people came and tried to talk, and they said, no, we won't talk to you. The people that did the report are not experts. They're not knowledgeable in what they wrote about, and that's a problem. There will be a response to that report collectively from people. I'm not involved in that, and it might take some interest in reading that as well. But I can just tell you the report, I'm disappointed that a federal agency will put out something that poor.
So you don't believe that these 61 identified pollutants that are designated and regulated within other programs in the EPA should be regulated at all within BioSolids?
Not based on the knowledge I have at this point and what I know about them. If you look at the source of those pollutants, there's not a lot of them. Some of them come from diesel exhaust. Okay, they get into your wastewater treatment plant, into surface waters, and onto soils. They're products of combustion. Some of them come from your Saturday afternoon barbecue. They're products of combustion. These are not things that are being introduced in a wastewater treatment plant, and they are not things that are present in the biosolids at high levels. But the Inspector General didn't bother to explain this to you. There are things that you're exposed to oftentimes much higher rates just by doing socially acceptable things on a daily basis. Somebody at the Inspector General didn't like somebody at EPA, and they took it out on them through that report.
That's the official position of
That's my
the
belief,
Department of
absolutely.
Ecology?
Absolutely, that is my belief.
Okay.
I've made no secret of it.
We've got a question here and then here, and then there.
As a farmer, I'm a fan of low-cost, available carbon, nitrogen, these things that seem very bioavailable, and the data supports something that I think is probably a little more, gets a lot more attention, but we have an enormous amount of leaking and under-maintained septics that no one really seems concerned about. And I just want to point that out. We've put a lot of attention on this, but when we pump it underground, we sort of out of sight, out of mind. Now my question, if one wanted to, above board, with certification and data and analysis, produce their own organic biosolids, is there a permitting pathway to do such a thing for a small producer? And what I mean by that is we may be pumping our biosolids out to then go be processed at a larger facility. But if I'm going to be using biosolids, I would rather be using my own biosolids that I know what are in them, to be honest. So I'm wondering if this has come up at a micro production. Again, I'm not talking about a fly-by-night type thing. I'm talking about, I have an advanced degree in biology. I would love to do this type of stuff in an above-board way. Has that come up for a small producer?
If you're talking about, yeah, we do occasionally get this question, particularly around areas that don't have accessibility to regular service.
Reiterate the
Okay,
question
so
again,
the question was, as I understood it, was about the viability on a very small scale for maybe an individual service provider or an individual septic tank owner to remove their material and find a way to land apply it, doing it properly with a permit and approval, but not in the context of these larger operations and more complex permits that we see issued right now. Did I capture the question? Okay. So, unfortunately, it's one of those no and yes questions. As far as pumping septic out of your tank and say putting it on your own property, no, because the local health department regulations, they're not going to generally allow you to do that. And we would have, even if you could do it right, your next door neighbor wouldn't. We breed too many problems by taking that approach. An individual pumper who, say, wanted to selectively go around and pump tanks and run a thoughtful business with a land application site, absolutely, we do that. You do have to go through a permit process for that. And then on a really small scale, we get this question quite a bit associated with things like waterless toilets, sometimes called composting toilets, and particularly in remote areas or lesser serviced areas. and what they can do with that material. The official position of the Department of Ecology is that that material is septage, and it needs to go be handled by a professional who has an appropriate license or permit to do that. The problem is, a typical pumper will not drive up and pick up your bag of dewatered, waterless toilet material. So I tell people that's the official position of the Department of Ecology. That's the answer I can give you from the State Department of Health. Now, when we hang up the phone, what they do with what's in their composting toilet later on, I don't know. But we've thought this through and talked about it a lot at the when the program was being developed, and there are a number of problems that ensue. For example, I have a cabin in the woods, and I take my family up there, and I diligently use our composted biosolids, and I put it out in the backyard, and I grow grass, and I tell the kids, look, just don't go over there. That's where we take care of our waste, and we do a really good job. Then I sell my property, and the new person comes in, and they don't want to maintain the waterless toilet, or they want to grow carrots where I was putting the stuff that I was doing. There's no way in terms of a chain of custody to manage. There's too many problems. So I would love to see something come through like you're talking about, and we're always open to those sorts of things, but I don't see a mechanism right
There
now.
is a state-approved list of composting toilets.
Right, but that's a list that approves the device, not
So
the
we're
product
missing-
that comes out of it.
There's a
Yeah.
gap that I want to highlight.
There is, and that right now,
Research.
my answer to you is put it in a bag, put it in your garbage can, and goodbye. And I don't really think that's a really satisfactory answer, but it's the legal answer I can give you.
I understand, thank you.
Can we go
Wait,
here?
wait,
and-
before you
oh,
go.
I'm
You
sorry.
made one comment about organic. What do you mean by organic?
Oh, not capital O.
Okay.
Okay.
Yes, thank
Yeah,
you.
I missed that, yeah, okay.
Although we do eat organic and
Yep.
if I was going to use, but I know where you're going and that's not what I meant.
Right, the question was about organic, and biosolids is not a certified organic material.
Okay, so I think we're here, here,
Sarah?
and then back here, and then here.
I have a question, because every time we talk about like the public safety issue around some of it, again, a big knot in my stomach, because when they applied it here in our county a few years back, it was Class B, and we were not really notified of the dangers of any of that. And I had a toddler at that time who definitely was exposed daily for like a month. He'd fallen, he got cuts, I mean, toddlers always got their hands in their mouths, stuff like that, and I really feel ill when I hear how nobody should have come in contact with that, and our entire families were, because it was down our roads and our driveways, and it's, I guess my question is that something I should have major concern over? Because, I mean, little kids, you know, are always licking their hands and fighting and
Yeah.
teething even at times during this.
I have 3 kids, they're not little anymore, and I have grandkids coming along too, so I get what you're saying. Can I ask some clarification from you? So, biosolids are being applied to an area of land, and your toddler was walking around on that area of land and...
No, but our entire road was so covered in it that it tracked into our driveways, on our shoes.
Not okay. So let me give you and this is over and done at this point, so but in hindsight or maybe for future benefit, so you're supposed to keep the biosolids in the vehicle when you transport it from one point to another.
Yeah.
Now, I had somebody recently who exploded over an amount of biosolids that got dropped on a road in eastern Washington that didn't, a deer going down that road would leave more material behind, okay? You have to be, I'm serious, it sent me pictures and I'm like, where? You know, that's, you know, you gotta be reasonable, but what you're describing to me, spillage on a roadway going to a
They
site,
repaved it, it was so bad, like there was no cleaning it.
that's not an acceptable practice. And if you notify the Department of Ecology, this young lady right here, Amber Korfman, if you call her and tell her, in fact, I think if you were to call your local jurisdictional health department and just mention to them, they would probably go more quickly than Amber because they're here locally. We will address that, and that can result in, it could, depending on the circumstance and how bad it is, it can result in a don't do that anymore, clean it up and go say you're sorry. It could be, we could write what's called a notice of correction, which is a stronger step up, We could issue an administrative order, which is yet stronger. We could add a penalty on top of that, and we could remove the permit for that. It depends on the seriousness of the violation and whatnot. But yeah, you know, honestly, if I lived on a street where that was going on, I would be calling me, or I'd be calling him.
We weren't given the information back then to know
Yeah,
even the
So related
dangers
to
of
this
it.
incident, does the Department of Ecology have any obligation to verify a SEPA?
Okay, so I can answer that question, but I don't want to be the, Sarah, do you want to, that's a whole different question. So do you want to,
Well, it relates to transportation.
well, but SEPA is a whole different thing, and I'm perfectly happy to entertain that, but I want to be sure that people are getting their questions addressed in the right order, or we're going to be off on a rabbit trail.
So let's hold that tight for just a minute and come here.
And mine is kind of related. When we, the question came up about how long to stay off a Class B application, and you said there was a range depending upon whether there was a high potential for public exposure. Would that be within a neighborhood rather than one of these big fields like out in eastern Washington, like a little 20-acre plot between all the houses?
No, they're really not talking about the 20-acre plot between the houses. They're talking about the active use of the site. So for example, you have a site where they want to apply biosolids in, let's say, March of the year. But along about June, they want to have a big community picnic out there and fly kites and that kind of stuff. No on that. But let's say you apply biosolids in March, and along about June, somebody who fishes for steelhead wants to trot down and fish for summer on steelhead in a river, and you're the property owner and you don't care if they cross over your property. We don't care either. You just say, hey, Jack, you know that we put biosolids out there, so just walk straight across and you know, don't sit down on the spot. That's kind of the high and low exposure that we're talking about. EPA, I think, actually used a different example, which I think is sometimes government agencies can be a little out of touch. One of their examples was cemeteries. And I'm just thinking of how you would apply Class B biosolids in a cemetery and how that would go over with people. But that's an area of high potential for public exposure, along with parks and places like that. And I'm like, no, we don't do that. If it's going there, it's an EQ product. It's a fertilizer, basically.
Can I follow up? When it's a dry, when it's applied in a dry or semi-dry, or it's drying on the surface to complete its, you know, its cleansing, can that blow around? I mean, because we're in a high wind area as well, and so this is on the surface, it's in the driest part of the year, and it just sits there.
So the question was, can biosolids blow around or blow off the site? I suppose very dry biosolids sitting on the surface of the site, just like dust, could blow off a site. They have done some research on aerosol transmission of pathogens in biosolids and generally not identified a problem there. So I don't think that's a high risk, but it's something worth bringing up in a permitting process, or because there are things you can do. For example, you can subsurface inject, you can till, you can vary the time of the year that you apply. One nice thing about being very dry is desiccation is a really effective way to kill many pathogenic organisms or other organisms that might remain in the biosolids. When you dry it out, that's how you kill things. That's one of the things that will kill things. Also, leaving it on the surface of the ground, ultraviolet radiation is another benefit. So,
In terms of stuff blowing around, some of that research has been done in Washington, and as Kyle says, it doesn't really blow around very much.
My concern would be all of us with our gardens, you know, within a block of, or less of this field. And with the constant winds in our area, we're in a very high wind area. And we have our gardens and our orchards and our berries, things like that. And so that would be a concern some of us have because we're so close to the site. It is dry. It sits on the surface and the wind blows at, you know, 20, 30 miles an hour.
I think honestly, I understand your so the question we're pursuing here is continuing high winds, blow off onto, you've got some boysenberries or whatever you have growing on your site and you're concerned about those. I get that. We don't have any evidence of any problems associated with anything like that anywhere. But and it's really hard to answer your question for you in this context. I would say that that's the kind of input or comment that you should provide during a permit process for a site during that public. you should put that in there. At least somebody should think about that a little bit. Sometimes there are ways to mitigate those potentials. You know, and I can think of examples, you know, not necessarily in your context, where people have made adjustments to practices at a site to get around to address some local concerns. So I would say bring it up. I don't have an answer for you, but bring it up so it can get thoughtful consideration and get in the record. I mean, that would be my best advice.
I hate to say this, but our program is scheduled to go till 8 o'clock, and I know that our speakers have a ferry to catch.
It runs till 1 o'clock. I just want you saying the state guy ran out of here.
Kyle's driving, so when he leaves, we leave.
Okay, so we do have a little more time, and I want to go in order. I'm sorry, well, I'll get to you. But we've got a question here, then we're coming back here, then
And
here,
if we have
then
time.
there. All right, so go ahead.
So I had asked a more narrow question to Georgine, but I believe you were off in the other room, Kyle. You mentioned something about you believe there should be monitoring programs for emerging contaminants. In drinking water, I think you said that. In drinking water, there's the ECMR3 program for looking at emerging contaminants. Is there anything similar for biosolids that look at pharmaceuticals, PFASs, things like that that are coming up as new and concerning issues?
So the question was, for biosolids, is there any deliberate sort of program or research effort that looks at these emerging contaminants, things of concern, like PFAS was one that you mentioned. Yeah, I think it's fair to say there is, but there isn't a strict mandate. Normally, we share things around. So if somebody mentioned bisphenol earlier, BPA, if it's a concern in drinking water, if it's a concern in surface water, it's a concern for biosolids. So we all tend to look at the same emerging compound for concern. So if somebody is looking at an emerging contaminant of concern somewhere, it's likely getting picked up, and there's research in biosolids. It would take me a few minutes to talk about PFAS and some steps the agency's taking about that in particular, but we are doing things specific to PFAS right now. But so I guess the answer is yes, except there isn't a formal thing that says, here's what constitutes an emerging compound or an emerging contaminant of concern, and this is what you have to do about it. We don't have a specific mandate like that for biosolids, but other programs do look at those things, and we pick up and work cooperatively.
Okay, help me remember, who was next? Right here, yes, sir. Yep.
Yeah, sources like National Geographic tell us that third world countries where human waste is used for fertilizer causes a lot of epidemic problems. What can you tell us about the process that makes it so much better?
Is that for me, or?
I'm not quite sure. Question was, how we process material in the United States as compared to third world countries and the benefit from it. Generally in the United States, not generally, in the United States we go through steps of pathogen control so that we're treating pathogens and biosolids. When you're going to third world countries where there's no processing going on, you're left with raw manure and you're going to have pathogens.
How is that done?
It's microbially derived through heat.
In other words, it's like kind of like the septic system where it's set and allowed it's a time factor, allowing the microbes to do their job.
I think I understand your question, so let me just expand a little bit more on this. Okay, so wastewater treatment, there's a fellow named J.R. Inman who works for Northwest Cascade or Honey Buckets down in Pierce County, who has a fairly interesting presentation in his experiences working with the Gates Foundation in India and Africa, highlighting what you're talking about. And if you look at what those people deal with for sanitation, you will feel very fortunate for even an overfull outhouse on a hot day at the county fair looks good by comparison, okay? Here, the sewage that comes into a wastewater treatment plant goes through a long range, many steps of treatment to result in the water that comes out that's discharged to Puget Sound or to a surface water to a river. The biosolids then go through a treatment process where we monitor time and temperature. They're tested for pathogens or for indicator organisms. They're tested for pollutants. There's a whole difference. Comparing wastewater treatment in the U.S. to these third world countries is kind of like comparing a Cadillac to a tricycle in terms of what goes on. If you've never visited a wastewater treatment plant before, I would strongly encourage you to call them up and see if they have a tour available. It's really interesting and enlightening, because many people think the typical wastewater treatment plant operator, kind of a green-toothed guy who hides over in the corner and they play cribbage all day long and they eat sandwiches with dirty hands and the place stinks. Seriously,
It's true.
It's true? Okay, well, I can't speak for all. It's not what you find. You find real professional people really concerned about the environment, working in an area that they try to keep clean, because they're right there on the front lines on a daily basis. So it's a matter of treatment and monitoring and documentation and paying attention. It's a huge difference between what we have here and third world countries.
I was just kind of curious as to what is it that's making the difference? Is it anaerobic? Is it aerobic?
Okay, so wastewater treatment, basically, you can think of wastewater treatment, a good way to think of it, and that includes your septic system. It's like liquid composting, okay? So you put a pile of grass clippings together on a warm day and it starts to decompose and it gets hot. That's done by microorganisms. In wastewater treatment, you're growing microorganisms that eat the stuff that comes into the wastewater treatment plant. So you're using the microorganisms to eat the stuff that you don't want. Then you use a process to remove those microorganisms, and that's really what your biosolids are. It's the wasted microorganisms you're removing from the process after they've done the job of eating the stuff that came into the treatment plant to begin with. So it is like liquid composting is the simplest, easy way to think of it.
Yeah, the way I refer to it is liquid composting, or what happens is we have our human waste comes in, goes through a digestion process, either anaerobic or aerobic, depending on the plant, and that basically microbes start to chew on our waste. They die, they fall to the bottom of the tank. They then separate the liquids from the solids. The solids are then, again, redigested, and they'll go through again a plant where microbes chew on these old microbe bodies. They die, fall to the bottom of the plant pile, to the bottom of the tank. They're separated from the liquids and the solids, and the solids portion become biosolids. And when I mean liquids and solids, the biosolids could be pretty liquidy or solidy.
Very liquidy.
But, they could be anywhere from 2% solids, which is basically a liquid, to 20 to 30%. They use dewater.
Short question. The permitting process. You have a piece of property, it's been permitted. How long does that permit last? And what's required for it to be re-permitted?
Okay, so the question was, for a permitted piece of property, how long does the permit last, and how long and what is the process to get it re-permitted?
If the permit has expired, do you go through another SEPA type process or what?
Well, in true government fashion, yes and no. All right, so we have treatment works that produce biosolids. They're the ones that get the permit. And then that site is part and parcel either of their permit or a permit under the management of a separate company, like we talked about earlier, for a beneficial use facility that manages the site. The question we get asked more often is, how long is it going to take to get my permit? Mm-hmm. And that's what's at the heart of some of the changes in our general permit program, trying to make that a little quicker and more expedient. But it can take several months to a year or a couple of years to get a site permitted, depending on how complex it is and the quality of the application. If you come to us with a good quality application with all your ducks in a row and you've done your homework, you can get a permit in a relatively short period of time. Not everybody does that, and I'm sure Amber can testify, and I can tell you personally, it becomes a real battle, because it's like a teacher. You got a D, you hand it back. No, it's a C minus, you hand it back. So there's that process. Right. Then the permit is good for the life of the general permit that it's issued under. The general permit is really the permit. Everything else is an authorization to operate under it, but you can think of it as a permit.
The general is with the facility and not the property?
Well, everything is under that general permit. So the general permit's up here. The facility is approved to operate under and consistent with that general permit. We may add some additional requirements to the facility. Then if there's a land application site, it's under there also, and we may add more requirements there. For example, we have no way of knowing what a required buffer might be for a site to protect surface water. I mean, we can have a generic one, but that doesn't mean, if a facility comes and gets a permit, we don't have a land application site, we don't have any way to say. Maybe it's 10 meters, maybe it's 100 feet. So those things have to be settled out later. So they're all under and part and parcel of that permit system. They're all good for the 5-year life of the permit cycle. Every 5 years they got to renew and do a public notice. It probably will roll forward, but it depends a little bit on circumstances. If the operator hasn't been a good actor, if there have been problems, they can jeopardize that permit standing. If the site conditions have changed so that it's no longer what it was when it was proposed originally, that could affect things. So it isn't a rubber stamp, but if nothing has changed, if everything is equal and they're managing it properly, then it would roll forward. There'd be no reason not to allow it to go forward.
All right, my last and follow-up question, how does the public know that it's ready to, to roll this forward or to make a protest on something that may be, have changed?
So I had a couple of slides in there earlier today, but the way that, like I said, the way you know that is that you habitually read the legal notices in your newspaper of general circulation, etc., or you get on a mailing list with the facility, write them a letter and say, I'm an interested party, ask them for a return receipt, get a return receipt yourself, notify the Department of Ecology and say, when this thing comes up for a permit, I want to be notified. Take some proactive steps on your part, and you certainly are entitled to be notified. You can attend a public meeting, a hearing, you can comment, and you're entitled to a response to your comments. That maybe you may or may not like it, but you're entitled to your say and to be heard.
Yeah. Okay, thank you.
Okay, let's take a couple more questions. I think we have one here, and then you may have a follow-up question on SEPA, or no?
Well, I asked the question and you told me to wait. So.
Okay, so we do have a follow-up. Okay, so 2 more questions. Go ahead.
I was just wondering if there was a state-produced map or list of permitted land application sites that's available to the public.
Oh, I wish.
Question.
So the question was, is there a state-produced map that shows land application sites available to the public? City of Tacoma has a really nice map. I don't know if Dan's going to, it wouldn't be of concern to you, but the City of Tacoma has a really good map of their customers. It's very impressive to look and see where their biosolids have been distributed over time.
What kind of material do they make?
They make an EQ product, a Class A material, low pollutant limits, and people come and get it by the truckload. If you really want to know, there are files you can go through, they're all paper. We are shifting to a geographic information system, and we have some information in that so that we can get to the point where hopefully you can go online and say, well, where's the nearest biosolid site, and look, and then you can click and find out what was grown there. We just aren't there yet. It's incredibly costly.
5 years?
Well, it's in use right now, but it's not adequately funded, and we don't have a way to get out of it what we want. We have one staff member at least who's interested in trying to help us get more out of it. It's going to get better year to year, but it's not going to be next year that you can just go click and find everything in the state. But I think it's important, and we do want to have it. A better question would probably be to ask what's happened around you locally, and that's easier to answer. But we get questions like that all the time, and I just can't tell you.
Okay, one more here.
So my question is the same question that I had regarding, does the Department of Ecology have any obligation to verify SEPA?
Okay, so SEPA is the State Environmental Policy Act, and anything that triggers, well, not anything, but basically a process that triggers a permit or approval by a government agency that would impact the environment is subject to review under the State Environmental Policy Act. And the review starts with what's called a checklist, an environmental checklist. I'm not trying to talk down to you here, I'm just trying to make sure that everybody here understands. I have a feeling you know a little bit more about this from your question. Okay, so the environmental checklist has a range of questions. Some of them are site or project specific. Some of them are more programmatic at a higher level of things. the proponent of the activity is supposed to answer those questions correctly and truthfully and completely. And then the SEPA official, and the SEPA official is a person who's vested with a specific authority to evaluate and make determinations under the State Environmental Policy Act. The responsible SEPA official is the person in the agency responsible for that determination and not anybody else. In some cases, that responsible official is at the local level. In some cases, that responsible official is at the state level. But we don't overturn another. If you're asking me if a small jurisdiction made a SEPA determination and we disagreed with it, would we go in, or do we have some obligation to go in and verify what they've done and approve it? And the answer is no. We do have some ability to challenge things, but if you challenge things, and now you're getting into the realm of SEPA that attorneys earn good money for, but if another agency challenges the threshold determination of a primary agency, they can end up being responsible for the entire writing an environmental impact statement, etc. So it's not something you see happen very often. So that checklist is designed for the responsible official, whatever. Generally, it's the lowest level of government that has a responsibility to issue a permit, which oftentimes is the local level. That's who makes that determination. And just so you know, the threshold determination under SEPA is a likelihood of a probable, or a probability, a likely probability of a significant adverse environmental impact in a range of areas. Transportation was mentioned, soils, water, surface water, groundwater, but it's a likelihood of a significant impact. It isn't the possibility of an impact in some, roadrunner coyote kind of scenario where if this happens, maybe the mountain will fall away and the cliff will be left standing. The SEPA official has to look and believe that there is a likelihood of significant environmental impact, and then there's more environmental review done after that. And that's probably the best answer I can give you. I can't speculate on if somebody does a bad job on, I can tell you this, if somebody does a bad job on a SEPA checklist for me, I kick it back. But if I know the answers, I don't necessarily have to do that. There may be other information available for me to review when I look at a checklist, so it just depends. But I certainly have returned SEPA checklists and said you didn't do a good enough job.
Okay, I would like to thank our speakers very much. And answering some of our questions. If you have any more, you can grab a card and we can see if we can get them the right way.